Hello everybody, I'm going to do a video on how I'm repairing my broken bandsaw blades. This one that came with my 4x6 saw is still razor sharp, just plain carbon steel 14 TPI. It broke at the weld joint shortly after getting the saw, so I went out and purchased a 1014 bimetal blade for cutting harder materials like stainless steel, for example. It snapped a year or two back. And then also at that time had purchased just another standard carbon blade that just broke a few days ago. It's been on my radar to do this for a long time. I'm now going to do it. All these blades are still razor sharp. They're just broken. This is the one I've already done using a makeshift cobbled together jig to hold everything. I'll show that momentarily. But I'm brazing these using a high temp brazing flux, had it on hand, and then a year or two ago I'd replaced a refrigeration compressor in one of my dad's vending machines for like sodas. So we bought a trolley ounce of this 45% silver solder. Other people that are doing this are using 50 or 55, somewhere around in there. This is what I've got, so that's what I'm using. So I'm going to step through this and how I do it from A to Z. And this is my very crude makeshift setup. It's just a couple pieces of aluminum, a couple machinist clamps here. I dressed the ends and laid the blade right here in this gap. Clamp, raised it up. Alright, well I've got the blade mounted back up here. Now when I set this joint, I had the scarf a little too far overlapped, so it's actually a little offset from one to the other. This is what we're trying to achieve. There's the scarf joint, and then the blades will come together like this and the solder will flow down through there. Here's a representation on what I have right now. Even though I dressed this down, this blade cross section is still offset from one side to the other, and you'll hear it as this joint comes around. So let me turn the saw on for you. You hear the click click as it goes through these guide rollers. This is at least going to get me going, and I can always go back, break that joint, and reset it with the new jig if it becomes a problem. Alright guys, well I've rifled through some of my stock and scrap and whatnot, and these are kind of the candidates for making it. This brass would be a perfect candidate for it, but that just seems excessive in my opinion, cost wise, so that's out. And then I had a couple of pieces of scrap steel laying around. I'm like, well, I might be able to get something out of that. But this piece is like a 1/4 inch thick, so that's overkill. And this does not have a flat edge right here anyway to accept the blade. I'd have to do filing or milling or whatnot. And that brings me into aluminum. And I'm trying to do this in a way where some of you guys might be woodworkers and not have milling machine, lathe, stuff like that. So I'm going to try to pull this off just using basic tools. Just miscellaneous scraps of aluminum. I saw toe clamps in this, which I'll end up not using. I'm just whittling down things that I've nixed. Piece of 6061, a little bit too thick. This is kind of where I'm at. I've got this piece of 6061 T6, which seems overkill for its thickness, and it would be better suited for something else. Plus, it's not quite straight. So that's out, which brings me into this arena. This is just structural aluminum as well as these pieces. Aside from this hook on the end, this is big box store stuff, really. I believe what I'm going to do is utilize this piece along with one of these thin pieces, and this piece will be affixed right here to make the ledge. Now it's not quite as wide as I would like it. I think this is 3/4. I'd rather have closer to 1, but it might be a benefit. So the blade will sit right in there like that, and it will get held down with a couple of toe clamps, and there'll be a notch somewhere out here in the middle. if by chance I ever use, let's say, a 3/8 inch blade, these are 1/2 inch, I could still probably do that blade in there. Let me take a peek here real quick. Yeah, that's only a 1/4 inch, so I could do a 3/8 blade, and stretching it maybe a 1/4, but the teeth would hit the edge. So this is what I'm going to go for, and because of the shape on the end, I'm going to actually use that to my advantage. I'm going to cut this off around in this arena, and that is how I will hold it in my vise. And I'll do my soldering right out here. So speccing this out, if I used, let's say, 3 inches to support the blade right here, and then I gave myself a gap to work with, let's say 1 inch. Let's see what that leaves me with. Yeah, right around 3 inches on this end where we hit that bend right there. So that's what we're going to do. I'm going to start by cutting this off somewhere just below this, maybe right there, and we'll start moving on. Well, when I said basic tools, I didn't think I meant it that literally. I'm going to cut this off with a handheld hacksaw. I do not want to break out my vertical bandsaw just to make this one cut, so we'll just get this whacked off here. I'll clean that up with a file on the end, and we'll move on again. Alright, well this stuff is really gummy. I forgot how bad it was to work with, especially with filing. But we got it close enough to being okay. Now I'm coming in here 3 inches right there, and I wanted a 1 inch gap. But the way I'm going to take this out, I'm actually going to mark it on the back side. I want it to come out right here. So I'm going to mark from this edge on the other side. This will become clear here in a moment. So we're coming out to 3, over to 4. Go ahead and just get a line in here. This is not exact, it's just good enough for what we need. And then I want, since with this on there we've got a 1/4 inch gap, I want it an 1/8 inch back. I'd like this to be wider, but it's what I've got. So we're going to come this direction 3/8 and 3/8 right here. And I'll connect these lines and we'll move on. Alright, I've got it marked out. This is the area here we're going to be taking out. Alright, well I am going to use my bandsaw for this. I'm just going to come down until I touch that line, controlling the depth with my hand. And then I'll just slowly whittle across, kind of like you would do on a piece of wood. And then I'll clean it up with a file. You could do this by hand, you could file the whole thing, or use a jigsaw. Your choice. Here we go. Stopping just shy of the line so I can file it flat because the blade is coming in at an angle. So I'll get this lined up here. And then, like I said, I'll just whittle out the rest of it a little bit at a time. Alright, well here's what I was talking about. Just kind of made little combs in there. That probably took about 5 minutes. I'll get in here and break these out. This could even be done by hand with a handheld saw if one was so inclined. But I need a screwdriver, but I'll snap these out of there. Alright, you can see I've pretty well got that cleaned up. I've cut this piece to length as well as laid it out. I've got 3/8 inch in, centered up 1/4 inch, 3/8 from the gap, which are these 2 marks, and then same on this other end. So I'm going to start by center punching these. And once I get all 4 of them punched, I'm actually going to clamp this on here and drill straight through both of these pieces in one shot. And I'm going to use, I think these are 632s. I found they're too long, but they're actually going to bolt this on here. So I'll cut those to length when we get there. Alright, well, I'm tucked in the corner with you, so I'll try to keep my hands out of the way. It's hard to shoot shots like this. I've got it clamped on. You may not be able to see both clamps. Got it lined up. I'm using I believe a 56 drill bit for a 632. Let's turn on a light here and see if that helps a little bit. Alright, this has got a little spring in it, so I'm going to hold it down. I'm piercing through both of these at once. And spinning a little slow, but we'll try it anyway. Alright, we got through there. In lieu of transferring holes, I'm doing it this way for people that don't have all the tools. I'm going to tap both of these at once, and then I'll drill a clearance hole in this top bracket after the fact. I'm just putting in a little center right here to help guide the tap. Hopefully I can fit in there. Oh, just gonna make it. Yep. Put a little cutting fluid on my tap. Get lined up here and just, it's gonna help start it straight. I'm hitting my clamp. Try to turn that a little bit. Still hitting my clamp. I gotta move this one clamp. Hopefully everything stays put. Sorry about the delay. Alright. This is a very small tap, so I'm going in carefully. Just get it started a little bit. Alright, well, I've got that hole tapped and I've got a screw in it holding it. On these small taps, you have to extract them quite a bit. They don't accept a very big chip load, and if you get too overzealous with it, you'll snap it off in a heartbeat. I'm going to do this one the same way, and once I get the fastener in there, I can remove these clamps and do this side over here, and that'll ensure perfect alignment on all the holes. That's why I'm doing it this way. Well, alright, I just gave a warning about being careful with these small taps and not getting too greedy and clearing the chips off, and 1/4 turn too many. I snapped that tap in the very next hole. I was able to take this top plate off, and I've got a little bit of it sticking out. I don't know if I'll be able to get a hold of it to get it out. Oh, it's crunchy. Let me be careful about this and see if I can get it out of this hole. If I can't, I'll just need to pierce another one beside it and hope I have another 632 tap. Alright guys, I was able to get that busted piece of tap out of there. I had to break it up with a punch. I was able to salvage the hole. I got this taken care of now. Of course, I didn't have another tap that size, so I went down and bought a couple. So now I'm back in action. I'm going to do the same thing with these 2 holes, hopefully with no mishaps, and then we'll continue on. Alright, well, this part's finished. I've removed my fasteners, but before I did, I put a witness mark right here and here, so I would know exactly how this came off. Taking it off, I think I said I used a 56, number 56 drill for that 632. No, it was a 36. I'm going to use a number 27, which seems smaller, but it's actually larger. just to drill these through to make clearance holes. So I'm just going to do it on my bench right here, right now. Do one, make sure I've got my clearance, and I do. That's that. I'll use a countersink bit to deburr this hole. You could use maybe an X-Acto knife. Actually, a larger drill bit would work. Just kind of do it by hand like this and knock the burrs off. Same principle on this piece minus the clearance hole. I'm going to use my countersink and the drill to knock the burrs off the back, especially where the bit came through, but also right here. Just put a little chamfer on that. Just like so. Alright, well, I've got this mocked back up with the exception of one screw right here. These are too long. That's where I'm at right now. Some different options to cut fasteners down, bolts and screws, whatnot. If you're going to cut something, put on a nut first, then cut it. Either a rotary tool, abrasive tool, or a hacksaw, or maybe even some side cutters. And as you take the nut off, it will reshape the threads and make it back the way it should be. I myself am going to use these crimpers, which have a function in here where you can thread in a fastener like this and squeeze it and it will cut it off. And if it needs any reshaping after the shearing action of that, as you take it out from this threaded hole, it will correct the threads just like a nut. Now I want about 1/4 of an inch, and I've kind of calculated 3 turns is what I need on this to give me the length that I desire. So we're right here, and let's say that's a 1/2, 1, a 1/2, 2, a 1/2, 3. So right about in there should give me the length that I want. So it's just a matter of simply squeezing, cut it just like that. That piece rolled away. Well, this doesn't even need a screwdriver. Check my measurement here. That looks like it's pretty much right where I want it. Go ahead and see if it will thread in the hole. So far so good. Tighten that up, and I could probably stand to do actually another 1/2 to 1 turn. It is in there. I'm going to do the other one 4 turns. I'd rather it get closer to this surface, and if that turns out, I'll just make a new one for this. 4 turns was the ticket, just shy of the surface, which is exactly what I wanted. Now I'm going to use the same method I used earlier to remove this 1/8 inch of material right in here on this piece. I'm going to slice it, comb it out, break them off, and file it flat to where these 2 pieces match. Alright, well I cut that section out and cleaned it up with a file. It's looking good. I went ahead and made 1 clamp just to make sure everything was going to work right. This is an 832 screw. I don't have anything that I could use toolless at the moment for hardware, so screwdriver, no big deal. When I made this, I bent it past 90, so it sits flat down here on this edge, but you can see how it bears right on this back corner. That way when you tighten this up, it applies all the pressure right here to hold the blade down. To make that bend, I simply used this and said, okay, well I want the bend basically to rest right here in the middle of this flat. So we'll go over to the vise and we'll bend this. If anything, I want to bend it a little bit long on the tail side, and I can cut this back. Alright, I've got it sandwiched in my vise in between a block of steel and a piece of wood, just to help protect it. I'm going to use another block of wood and just drive this around. Just like so. And now to get that to bend over 90 degrees, I'll try to do this one-handed. I'm just raising it up a little bit, and now I'll tap it down more. That looks pretty good. So you can see I've bent it just over 90 degrees. That will give the bearings contact surface here and the clamping surface right here. Now I'm going to figure out where to mark this, and I'm going to cut it off. Alright, well I cut the clamp off just over 1/8 inch, drilled a clearance hole in it, as well as prepped the last hole like before. So that completes building the clamping jig. What do you say we prep a blade and test it out? Okay, I'm going to use my bench grinder to prepare the blade. I've basically just set up a piece of angle iron here on my rest, squared it to the wheel itself, as well as dressed the wheel flat. If you have a belt sander, belt grinder, you could do that approach. So I'm going to ride on this as a fence, and I'm actually holding the blade up a little bit to go directly into the wheel so it doesn't do an aggressive hollow grind. So let me turn this on and I'll do one side. I'm going to go in just briefly and pull out and let it cool for a second. I don't want to get this too hot. So here we go. It's not even plugged in. Well, let's try this again. Once I establish a flat on this, I'm going to check it with a square and make sure I don't need to readjust my fence. Try this. That looks good. Just flip the blade around and do the other side the exact same way. Alright, well the ends look good. Now we're going to create the scarf joint. And the way I'm actually going to do it is right about 3 inches back. I'm going to put my finger, and that's where I'm going to hold it. And I'm going to use that as a stop right here and rock this down, and I'll slowly grind away at that until I see the sparks come over the top. So let's give that a go. Alright, so now you can see what I've done there. I'm basically approximating, somewhere around 20 degrees. So what I'll do is I'll just flip it like I had it here. I'm just flipping it over end. Bringing the other side up, and we're going to do the same thing here. Again, using my same reference of 3 inches. And now I'll do this side. Alright, well I've got both sides dressed. So what we do now is we put them together as a test fit and look at the teeth and make sure we have a good tooth spacing. And that looks pretty good. If your blades are more aggressive, the spacing might get too far off. So you can take more material off and get it to your liking. But this is looking really good. Alright, the next thing we need to do is remove the bluing right here where we're going to make that joint just a little ways back. You could use a roll-lock abrasive, maybe a Dremel, sandpaper, whatever you like. I'm going to use one of these Sandflex blocks. This is a medium grit. I really like these. It's basically just a block of abrasive that's constantly wearing away. And I'm just going to go in here and clean this off. Quick and easy. I'll do a little bit more. Alright, well, everything's been prepped as well as thoroughly degreased. Cleanliness is the key to successful jobs when it comes to brazing, soldering, whether it be silver or soft soldering, or even welding. So I'll get this side in right here, get it clamped down. I'm just doing a test fit, making sure my gap is pretty well centered with the blade. Bring the other piece around and slide it in. Just going to tighten this one up loosely. Just feel where I'm at. Well, that already feels good right there. Maybe check it with this. I'd say that's good. Go ahead and snug this in. I think what I'm going to do, because I need to put flux in here, there's two options. One would be to put a small clamp right here, and you could take it out and put it right back where you have it without having flux all over everything where you can't see. Or in my case, I'm just going to lift up the blade, put my flux in, and let it go back down, and then we're going to braze it up. Alright guys, sorry about that, but the last two clips didn't work out for me. I tried to show the brazing. You couldn't even make out what was going on. And then I also tried to show how I was dressing the joint down after brazing. I just simply used a drum sander on my Dremel tool to do that. If you've got a roll lock with sanding disc, use that. Use whatever you want. But I've dressed it down and brightened it up out to the sides, because as it stands right now, even though this has been brazed, it is super brittle, super hard. So what we need to do is temper it back to make it a little softer, and it'll be more flexible. If we try to use it right now, it would probably break in pretty short order. But to do that, I'm going to fire up the torch. This may not work out either, but I'm going to bring a light straw color into this, hopefully to about right over here, even though we're not going to see it. So let me fire up the torch and we'll see if this will work. Very low heat. Something about like that. Just a light waving. Alright, I went a little bit too hot right here, as you can see. I was kind of shooting for this over here. Hopefully that makes out some. But we're just going to run with that. Alright, well there's the finished blade. It's not perfect, but practice will probably make perfect. It's only the second one I've done. Got a little warm here. Didn't quite get enough heat out here like I wanted, but it is what it is. Alright guys, well I'm going to try the brazing again. Maybe this will work out. I've got the bimetal blade in the jig. Clean the solder. Flux on everything. I'm going to light up the torch and start applying the heat to it, warming the solder just a little bit. And when I start to see this flux flow, I'll start testing the surface until it starts to flow the solder into the joint. This solder is a 1/16 inch, so a little bit goes a long way. It'd be nicer if I had a thinner wire, but I do not. So let's give this a go, see if we can get it this time. And I believe I got it. I'll take it out of here, cool this off, and we'll see where we're at. Alright guys, I give up. I was trying to show dressing the joint. I thought I was on record. I was on pause, so I missed the clip. Anyway, dressed it up, no big deal. Tempered it back a little bit. Hopefully you can see the straw color I was going for. There's a little hump, like when I heat it up, the blade is kind of deforming down. I don't know if that's going to be a problem. But what do you say we load it up, see how it runs? Well, alright guys, I've got the bimetal blade installed and tensioned up. Let's turn it on and see what it sounds like. Well, that seems to be running quite nice despite that little hump I was referring to. That may not be a big issue at all. That squeaking you're hearing is just the nature of this saw. Let's do a cut and see how it cuts. Alright, well this is a piece of, looks like a 1/4 by 3/4 aluminum bar stock. We'll just take a little sliver off of it and see how it works. Here we go. Well, I'd call that a success. Alright guys, well it seemed to do exactly what I wanted it to do. Works great. Just cobbled together from bits of scrap I had laying around. You could make something like this out of virtually almost anything. The only thing I would probably stay away from, just simply due to the flame, is wood. You know, folks may be wondering if this makes financial sense to do for fixing your blades, or maybe getting a coil stock and making your own blades up. You've got to do your math on that and see if you can amortize it out. I had this on hand as well as this, so I really had no outlay to repair what I had. Well, let's say for example you wanted to buy a coil stock of 100 feet and make up your blades to whatever length. In this case it's 64.5 inches. I think you can get about 18 blades out of 100 feet. And then you have to factor in the cost of this, as well as this, of course, map gas and a torch. But if you can find this silver solder at maybe even a higher rating at less than a 1/16, you guys saw how little I've used of this to make that last blade. It'll go a long way. This right here is probably my lifetime if I was to continue making blades. But if you've got a bunch of snap blades that are still good, let's say one blade cost you $15 and you've got 4 of them, you're at $60 right there. You can probably get this stuff well inside of $60 to repair what you've got. It's just an idea. It served my purpose. It's corrected my issue. Thanks for watching, guys. Hope this helps, and good luck.